Hello out there. Welcome today on this beautiful day. So we are working on statistics, but the focus of this lesson will be data analysis. Okay. What does data analysis mean to you? What does data mean? It's collecting information. What does analysis? What does to analyze mean? I think it's to think about data, make some conclusions, some conjecture, arrive at conclusion, or advise what must happen, okay, when you analyze data. Does that make sense? I mean, even during our pandemic, people are employed to analyze the COVID data, and they'll give it to our president, and we'll decide whether we're on lockdown or to ease the lockdown after the analysis of data, okay? So that's what we're going to do. We're going to look at data, then arrive to some conclusion. Okay. So what does data analysis mean to you? Does it mean anything? Okay. I mean, I think it's taking data. Whatever we have learned in statistics, data handling so far can be whisker plot, line graph, pie chart, frequency polygon, and represent data in one of the form and arrive to some conclusion by this analyzing data. Because if you have raw data, just random data around, what can you really achieve with the data? And another way of analyzing data, we can do our 5-number summary, our minimum value, quartile, median, and upper quartile. By having a whisker plot, what can we do with a whisker plot? Maybe if we calculate the semi-interquartile range and see the dispersion of the data before we make some conclusion. And just remember also the range, that, okay, the range is not a good measure of dispersion also, okay? That's what we're going to do. So analyzing data is collecting data, representing one of the form, then arrive at some conclusion, depending what are you trying to solve. Another question, is more electricity used in cold weather? What do you think about that? Yes? It could be, yeah, but because of winter, everyone is using a heater, maybe we're using more electricity, but I don't have sufficient evidence to conclude that. We need data to arrive at some conclusions. So for me to make an analysis to arrive and say, yes, we use more data during winter, I have to collect data from January to December, and I know our winter is around June, somewhere there, and analyze and say, yes, during winter, we use more electricity. That will be my analysis. So for now, it would be naive to say yes, because it's cold, everyone is using heater. Is it sufficient to arrive at that conclusion? No, we need a proper analysis to arrive at that. If I can represent this as a line graph, frequency polygon of January, frequency table January all the way to December, and calculate how much electricity we use each month. Yes, and I say, yes, in June, June is the model class in terms of using electricity, then I can conclude that. But what if in December people are using more electricity, which is possible because people are on holiday, people at home. So one cannot assume. It could be true, it could be false, but with data we can have a proper reasoning because we have a true analysis. Okay. So what are we going to, in our data analysis, what are we going to focus? We'll start with comparing two sets of data. I can compare two sets of data. And how do we compare them? And from there, how do we arrive at conclusion? Okay, so we'll look at two sets of data and how to analyze that, okay, and arrive at some conclusion. By comparing two sets, it just means two sets of data can be boys and girls, could be two salesmen, okay, and so on. And we'll look at pie chart. Because we know how to draw a pie chart. Okay, if you remember, a pie chart is more like a circle. How we draw it, we convert the proportion of what is given into an angle. Does it make sense? Okay, if I have 40 girls and 50 boys, I can draw that in a pie chart. I just have to say 40 divided by total, which is 90, times 360. I have to convert boys and girls into an angle, then draw a pie chart. But now we might have a pie chart. What does it mean to us? That's an analysis. We're given a pie chart. We read it. What does it mean? What can we conclude? What if there's change? What will happen? Okay, we're all together. So, and we'll also look at line graph, okay? And we'll look at box plots. Also, given box plots, what can we arrive at if you're given two box plots? But box plots are good if you want to compare two sets of data. They're very good for that. Line graphs, if you want to look at the trend, okay? I mean, if you go back, look at the COVID pandemic, all the way you can see it's more of a line graph. We had a peak, then the peak went down, then a second wave. A second wave when we record about 8,000 to 9,000 daily cases, a second wave was declared. But the question is, do you think the second wave will be higher than the first wave? How can we tell? We can look at that line graph and analyze. I think that can happen if we can get about 13,000 cases in the second wave. It will be, yes, worse than the first wave. Do we have provinces where the second wave is worse, is higher than the first wave? Yes, we do. If you look at the line graph, which is available all over the internet, you can see some provinces, the second wave, they have more infection than the first wave. And with restriction, they use the data analysis and put all the restriction to avoid that the second wave to be higher than the first wave. Do you think we're going to have the third wave? Is that possible? Will the second wave be worse than the first? It's a question. Can we really predict that? If you look at our line graph or data. Okay. So we need data to arrive at some conclusion and represent that. So line graph, we'll look at line graph also and analyze that, okay? And a bar graph also can be drawn to us and we can really analyze that. So let's look at some keywords, analysis, and distribution. I said analysis in this context, if data represented in this form, then I ask questions. What does it mean? Calculate all the measure of spread or measure of dispersion, your 5-number summary, and arrive at some conclusion. And by asking questions, is this better? Will the interquartile range, what does it mean? Why does this data have a lower interquartile range and the data have a bigger interquartile range? That's when we do an analysis. And when we talk about distribution, we're talking about distribution of data, which it could be symmetric, it could be skewed to the left, it could be skewed to the right. That's how data get distributed. So, we spoke about skewed, and we spoke about symmetric. When we talk about skewed, we're talking about skewed data, which could be to the left, right, and symmetric is when our whisker plot, this part of the block is the same as a block. So symmetric will be something like that if we draw our whisker plot. If this area is the same as that area, this will be symmetric. And for skewed, it could be skewed to the left or right. Let's look at that. So if this blocks, if you look at this block is bigger than that. So this is skewed to the right. This is skewed to the right. But we can have a case of a whisker plot where we have a whisker plot. This is bigger, but this is smaller. And this will be skewed to the left. Okay. Remember, this is our whisker plot. And how we draw this using our 5-number summary, okay, which is the minimum value, lower quartile, median, upper quartile, and the maximum value. Then you can decide on the skewness of your data. So in data analysis, we said we'll look at comparing data sets. Okay. We'll look at pie chart and line and box plot. So let's look at pie chart problem. There's a pie chart problem. Okay, what does it mean? So we have a pie chart here. What is important is to read it and understand. So we have here, we have prawns cocktail, an angle of 55 degrees. And we have bacon here, which is 35 degrees, when we can have ready salted at 135 degrees, cheese and onion, 50 degrees, salt and vinegar, which is 85 degrees. Okay. Does it mean anything? It's just a pie chart. What can I conclude there? By looking, I can see that ready salted has got a bigger area. But what does it mean? I can see that the bacon with 35 degrees is the smaller area. But what can I do with this? If I have a business and I want to order stock, based on my sales, I can see, oh, they're buying ready salted. That's what I need to order more. Does that make sense? I don't have to invest more into the bacon or the cheese and onion, which is third position in terms. Let's assume this was a tuck shop or something, or your spaza shop. Okay, but let's see what is required of us. So this is a pie chart. So what is have the following pie chart shows the favorite crisp flavors for 72 children. Now we have more information. So representing data only without some more info also, what does it mean? I can conclude whatever I conclude. So this is specific to 72 children. A survey was taken. Then what? Is there a question? There are many questions we can answer. It depends. So let's see what we have to answer. I can create my own question. Can I say which one is the most nice? Maybe ready salted, but maybe not. But let's see what is happening. So how many children preferred ready salted? How many children? Can we really tell how many children prefer ready salted? So we know that ready salted, we have 35. Are we all together? We have 35. 135. So what we can do on our pie chart, so we have 35 for ready salted, which is an angle. We have to convert that into how many children. So we know that we have 75 kids for the 72 kids for the survey. 72 kids took part in the survey. So what are we going to do? The question is, what is the proportion of children who preferred ready salted? How many? We can't say 135 degrees, 135 degrees. It's an angle. But how many? So we have to convert that angle into how many kids actually took ready salted. So this is how we're going to do it. So we have to convert the 135 degrees into some ratio. So we know that angles around the pie chart, it's what? 360 degrees. So it's 135 of an angle of radisalted over 360. We put that on a calculator. Let's see what we get. So this is what we get, 0.375. So 0.375, okay, of the total, which is 72, take radisalted. Are we all together? Then this is what we do now. So the number of children who preferred radisalted is this multiplied by the total, which give us 27 kids. Are we all together? Okay. I hope this makes sense, guys. This is another way. There are many questions you can answer from that pie chart if it's drawn for us. Initially, we had a pie chart. Then we can answer anything. What is the question? The question was, how many kids actually take radisalted? I hope to see you guys after the break. We'll look at more data analysis, okay? Probably something different. And remember, while you're sitting there, you need a pen and paper. You don't just observe. We do maths by pen and paper. Hope to see you soon.